Assalamualaikum. My name is Hadi Iman and my group member is Katifa Mehmood. Today we will be presenting the topic iterator patterns. To start with the introduction, the iterator pattern is implemented to provide a way to sequentially access elements of a collection like lists, arrays, or other data structures without needing to understand or reveal the underlying implementation of the collection. The abstraction allows users to interact with the collection through a common interface. By using the iterator pattern, developers can traverse complex data structures in a uniform manner. This consistency means that no matter how the data is structured internally, the method to access elements remains the same. By isolating the iteration mechanism, the pattern provides better code organization. It enhances reusability since the same iteration logic can be used for different types of collection. What is basically an iterator pattern? Iterator pattern enable moving through the elements of a collection one by one in a sequence, which can be especially useful when the underlying data structure is complex or when the collection needs to be iterated over multiple times in different ways. The pattern abstracts the details of the collection's implementation, allowing you to interact with any collection through a standardized interface. Also, it offers a uniform way to access the elements of different collections, making it easier for the client code to interact with various data structures in a consistent manner. Think of it like a TV remote control that lets you scroll through channels without needing to know the internal workings of the TV. For example, when you use a remote control, you don't need to understand how the TV processes signals or display channel. Similarly, with the iterator pattern, you don't need to know how the collection is implemented or how it stores the elements. The iterator abstracts these details, providing a simple way to navigate the collection. Now we will discuss the key components of the iterator pattern. The first one is iterator interface. It defines the method necessary for traversing a collection. Common methods are next, that is used to move the next element and returns it. Has next checks if there are more elements to traverse in the collection. Next one is concrete iterator. This is the implementation of the iterator interface and it keeps tracks of current position within the collection and implements logic for next and has next method. Aggregate interface is designed to ensure that a collection can produce an iterator. And the last one is concrete aggregate. It is the actual collection class that implement the aggregate interface. It implements the create iterator method to return an instance of concrete iterator which will be used to traverse its element. This is the UML diagram for iterator pattern. In this diagram, the client interacts with the aggregator, which is object that contains a collection of elements. The client calls the create iterator method on the aggregator to obtain a concrete iterator object, which is the concrete implementation of iterator interface. The concrete iterator provides necessary methods such as first, next, is done, and current item that allow the client to navigate through the elements of the aggregator. This was all from my side. Now Katifa will continue.
Okay, so now I will be explaining to you the benefits of iterative pattern. First of all, we have the benefit that it simplifies the interface for collections. The iterative pattern simplifies the interface for collection in such a way that you can access the elements of different collections. For example, let's take library system for example. Before using iterative patterns, we would have different methods for different collections. For example, for bookshelf, we have get book at, and for magazine rack, we can get something like get magazine at. So if we use the iterative pattern, then we can have something like bookshelf, which returns the bookshelf iterator, and magazine rank, which returns the magazine rank iterator. And all the iterators would have the same method, like next, to get the next item. And iterative patterns also supports multiple traversal strategies, like we have the forward iterator, which goes through collection of collection the whole collection from first element to the last element. And then we have the backward iterator, which goes from the last element to the first element. And then we have skipping iterator, which skips through every other element. The iterative pattern also reduces the complexity by hiding the traversal logic within the iterator access, within the iterator classes. And the iterator also allows the iteration without exposing the internal structure. What I mean by that is that the iterator pattern basically So the iterative pattern allows the iteration without exposing the internal structure of the collection by providing a standard interface to access all the elements sequentially. So those are all the benefits of iterative patterns. Let's move forward to the use cases. So the first use case we have is that the iterative pattern is basically useful in scenarios where you need to traverse different types of collections in a uniform manner without exposing their internal implementations, right? So the iterative pattern is perfect for implementing complex data structures that need custom traversal logic. For example, we have to implement graphs, lists, trees, and hash tables. Thereby, if we implement traversal method in those, we are basically encapsulating the traversal logic and keeping the structure hidden. So we can by using the iterative pattern, we can also access the elements of an aggregate object sequentially without exposing its underlying representation, which allows the libraries and frameworks to iterate over collections in a standardized and flexible manner, right? So those are all the use cases. Let's move forward to the coding implementation. So here we have a simple code for iterator implementation in Java. So firstly, as you can see that we have the iterator interface, which basically defines two methods: has next, which is boolean, and we have another item in the collection, which is next, which basically retrieves the next item. And then we have aggregate interface, which declares the method called the create iterator to create the iterator for traversing its elements. And then we have the concrete iterator class, which implements the iterator interface, right? So it takes a list of items during creation and keeps track of the current position in the list. It also provides the methods to check if there's another item. So as you can see that it checks basically that if it has another item or not, and then it retrieves the next item in the next that we have. And continuing that code, we have has next function method of concrete iterator. It basically checks the current position if it is less than the size of the items list. If it is true, that it means that there are more items available in the collection. So in the next method, for the concrete iterator, basically the next method retrieves the current position from the items list using the get function. As you can see that it gets the position to move to the next item, right? So and then we have the concrete aggregate class, which implements the aggregate interface. It contains a list of items to store the collection elements. The create iterator method creates and returns the concrete iterator initialized with the list of items for iterating over, right? So overall, these classes work together to enable iteration over a collection of items, with concrete iterator providing the iteration logic and the concrete aggregate providing the collection to be iterated over, right? So basically, to give an overview of the whole code, the iterator interface basically describes the method, declares the method for checking and retrieving the next items, and the aggregate interface declares methods for creating the iterators, and concrete iterator class basically implements the iteration logic over a collection, right? So the concrete aggregate class, last but not the least, holds the collection items and creates iterators for them. So in conclusion, the iterative pattern provides a systematic way to access elements of a collection sequentially without exposing its underlying structure. Right, so it boosts the flexibility by enabling the diverse traversal strategies without needing to change the collections interface. Thank you so much. That is all for the presentation.